So this is the second video of the lesson, and in this one we're looking at these two surd questions, both complicated expressions where you have to rewrite them in a particular form. So please pause the video again for about 5 minutes this time and try these two. Unpause to see the answer. So we'll look at the first one now. Just move this second one out of the way to give us a bit more space. So the expression here is more complicated. It has a surd in the denominator, but it has also just a normal number in there as well. So when you are simplifying this, you again have to rationalize the denominator, but you have to do so in a way that doesn't leave you with another accidental surd. So you can't just multiply by root 5, because if you did that, you'd multiply that by root 5 and you'd get 2 root 5, so you wouldn't have got rid of the surds at all. Instead, the method is to remember that these are both in brackets and to multiply by something called the conjugate, which is the same expression but with the sign reversed. So if it is 2 plus root 5, you're going to multiply by 2, subtract root 5. If it was already subtract, you'd multiply by the positive version. On the top, you multiply by the same thing. So it's 2 subtract root 5. You're not multiplying by this conjugate because you've got to multiply by the top and the bottom by the same thing. Otherwise, you've changed the value of the surd. So we're essentially expanding double brackets here. So we're doing 2 times 2, which is 4. 2 times negative root 5, which is negative 2 root 5. And then positive root 5 times 2, which is plus 2 root 5. And that's what you should see there. That's going to cancel out. That's the whole point of doing this, to get rid of those surds. And the final expression is root 5 times negative root 5, so it's negative 5 there. Because, of course, a positive and a negative times together makes a negative. On the top, the same sort of method. So we're going to get 14. We're going to get subtract 7 root 5. We're going to get subtract 2 root 5. So the surds are not going to cancel out on the top, but that's okay. You can have surds on the top of a fraction. And then we've got plus 5 there as our final term. Negative root 5 times negative root 5. Okay, so we've got to then simplify this. Well, start with the top. Looks like we've got 19 if we bring the 14 and the 5 together. And then as far as the surds are concerned, we've got negative 9 root 5s. For this one, you've got some root 5s here and some root 5s here. If you had something like negative 7x subtract 2x, you'd get negative 9x. While the x is just an unknown value, you can do the same thing with root 5s. How many root 5s have you got? Negative 7, negative 2. In total, you've got negative 9 root 5s. On the bottom, we're going to get negative 1. And as we said, it's going to cancel out the two surds there, so that's it. Let me write that in the middle. It's not quite in this form yet, but nearly. We've got to divide both the terms by negative 1. So it's just going to change their sign. So we're going to get negative 19 plus 9 root 5. And that's what we want. We want to figure it out in this form here, which we have done. So A would be negative 19 and B would be 9. So that is our answer for that one. Let's have a look at the second question. It's a very similar kind of working out, but a different step at the end. So here we've got a double bracket with some surds in there. I'm going to write it like this. And then I'm going to expand it in the same way as you've just seen. So 5 times 5, 25. 5 times 3 root 2 is just going to multiply that 3 on the front. You're not going to go inside the surd because you're not multiplying by a surd. So we're going to get, in this case, 15 root 2. Then very similar thing here. 3 root 2 times 5, same thing. and we've now got 3 root 2 times 3 root 2, so everything's being multiplied together there. We get 9 times 2, so the 3 times 3 gives you the 9, the root 2 times the root 2 gives you 2, so this in itself is going to be 18. We simplify all this together here, we're going to get 43, and we're going to get 30 root 2's. Okay, now that is simplified. That's actually how you'd leave it usually, but this question wants it in this form. So it wants it with root 8 on the bottom. Well, we've nearly got it like this. P is the 43. That's just the number. So we can say what P is, but how are we going to get this Q here? Well, to get it written like that, we're going to have to multiply this 30 root 2 by root 8, top and bottom. You can think of 30 root 2 as 30 root 2 over 1. So it is a fraction. Like any number can be a fraction, unless it's an irrational number like pi. But we can represent this number this way. Then we can multiply by root 8 on the bottom and on the top. That's going to preserve its value, but it's going to allow us to write it in a different way. Okay, so if we do this, we're going to get on the bottom root 8, which is what we want. If you look at the expression we're aiming for, it's something with root 8 on the bottom. So we've now got that. And what about the top? Well, the 30 will be unaffected, but we're going to multiply the 2 and the 8 together. So that's going to give us root 16. And then we can actually work out the root 16 because that's 4. So it's going to be 30 times 4 over root 8. And that means it's going to be 120 over root 8. So you wouldn't normally write an expression with a surd on the bottom, but in this case, this question, they want you to do that. So the answer for this question is 120, because that's the number on the top of that fraction in the place of the Q, which is what you were looking for. Okay, so those are the surds questions. We'll look now at some bounds questions. So we're going to do this one in this video, and then the third video is going to complete the set of questions. So have a look at this one, writing the upper bound for the width of this rectangle. Just pause for 1 minute and then I'll show the answer. So with any bounds question, you're given a value that has been rounded. So in this case, we've gone to 18 after rounding to 2 significant figures. So that's what it is now, but what was it before? You have to think of this process here. Something was measured, and then it was rounded, and then it became 18. It was rounded to 2 significant figures. The best way to work these out is to put down a number you think it could have been, and then round that to 2 significant figures, and if it goes to 18, then it's a valid number. And you're just trying to get the largest possible number that fits in that. So if we look at the example here, we could have, let's say, we could try something out. Maybe we have 18.9. Well, if you round that to 2 significant figures, okay, there's the first significant figure, there's the second. We're going to round this point here, but I think you can see that's going to round up to 19. So that doesn't work. But by trying that out, I think you can see how the rounding process is going to work, and then you can think backwards and realize that, okay, well, in that case, it's clearly not going to be anything like 18.9, but it'll be about 18.499999 and so on. We know as well, though, if we have this situation, we don't write this, we write just 18.5. That's because the bounds, by definition, are given as up to, but not including, this number here. So the upper bound in this case is 18.5. In the third video, I'm going to look at some upper and lower bound questions where you have to combine values. So I'm going to end this one here, and you can view that video right now.